All right. Part B. How do I find the rotational kinetic energy just before the block strikes the floor?
Oh, what is the rotational kinetic energy of the fluid just before the block strike?
Can you just take the one, just take like the one thing and compare it to the other thing, like those two, like cannot.
Yeah, when we said K rotation and we plugged things into it, we said I omega squared, and when we plugged things in, we got 1/4 m v squared. Okay? It's up here in red, right? When I have this right here is the rotational value. Okay? So as long as we plug in our values into that, if you solved for V, right? You just have to plug it into this. K rotation equals 1/2 I omega squared. And when we plugged it in I and omega, we got 1/4 mv squared. And when we solve for the kinetic energy using the speed we just used, we should get our answer, 43.6. Let's see. 1/4 times 8 times 4.67 squared. And that's it. Okay? So determine the amount of work done on a system until the block strikes the floor. Draw an energy bar chart that describes the system. Okay? Oh yeah, this is something we need to work on, is these energy bar charts, because I saw it's like free points in the AP test. That's probably why we should work on it the most. Okay. Work. Work equals what? Force applied. Okay. Times distance. We can also call it the change in kinetic energy, right? Alright. What's the change in kinetic energy? Kinetic energy, what minus what? Yeah, it's the initial and final versus each other, but we're going to go final minus initial, like temperature. Okay. Yeah. Yeah. We started off with, so this breaks down into kinetic translational and kinetic rotational, right? Okay. Wait. Let's just draw our before picture. Our before picture was easy. What kind of energy did we have to begin with?
Yeah, gravitation.
Gravity. Okay. What I would do right now is solve for the gravitational energy that we started with, mgh, and give it a number. Okay. So 98 joules of energy, and that's at the top. That's our before energy. You told me how much energy is in translation on rotational? The total is 98, so the other two are 0. Okay. In the after picture, how much gravitational energy do we have if we've hit the floor?
0.
Okay. Okay. 43.6. Where did we get that from? It should be the answer to part B. And slightly above it at what? 98 minus 43. So that's 50. 54.4 joules. That's it. Not drawn to scale. Why? I was gonna say because this bar is almost as these two are too tall compared to this one. If this was 98 way up here, but it's not. Okay. I should have made these shorter. In other words. So I should say, hey, 98's up here. Sorry. So that's the total amount of work done on the system, though.
Still 98.
It's all of it, right? We had potential energy. We transformed it. That was work being done.
So it's just 98.
And that's what I was saying with this over here. We've got both parts contributing to the work value, the change in kinetic energy. We had 0 kinetic energy. Now we have a lot of kinetic energy. Work was done.
Yeah, because there's some kinetic energy at the initial, right?
Yeah, there you go.